Welcome to Module 5, Lesson 9, Comparing Estimated Probabilities to Probabilities Predicted by a Model. Okay. Well, this lesson should be pretty quick and is actually a much better lesson for the classroom than it is for this format. So we will do the best we can to make it interesting and fun. Honestly, to tell you beforehand, I'm not sure how much you'll learn about this way without the discussion that should or would ensue in a classroom setting between you and your classmates. But well, we'll do the best we can. Okay, so let's go ahead and get started. All right, this is an exploratory challenge. Like I said, it's better suited for the classroom, and it is called Game Show Picking Blue. Okay, it's Game Show Picking Blue. So you're going to imagine for a moment the following situation: you and your classmates, okay, are contestants on a quiz show called Picking Blue. There are two bags in front of you, bag A and bag B. Each bag contains red and blue chips. I actually have red and blue tiles in these bags here. You are told that one of the bags has exactly the same number of blue chips as red chips, okay, which is true, all right? But you are told nothing about the ratio of blue to red chips in the other bag, okay? So that is true of our situation. One of them has a 1-to-1 ratio of blue to red, okay, and the other is a complete mystery at this point. All right. So each student, each student in your class will be asked to select either bag A or bag B. Okay, so what you're trying to do eventually is gain the most tokens. Let me just continue reading here. So starting with bag A chip is randomly selected from the bag. Okay, after mixing up the chips in the bag, another chip is randomly selected from the bag. So you keep putting the tile back into the bag, and we did this in class one day. Those of you who were there that day, we're just going to pick a tile, take it out, record it, throw it back in, pick another. Okay, it's just that whole process. Keep replacing. Okay, with replacement. All right. So if the chip is blue, the students who picked bag A to win get a token. All right, you'll win a blue token. So every time those of you who select, and you're going to pre-select a bag, you're going to say, hey, bag A is going to win, or bag B is going to win. Okay. Every time that we start with A, and if you're on the A team, let's say, each time I pick out a blue token or a blue tile, you will get a token or you will get a point. Okay, let's call it a point here. All right. Now that continues until a red chip is picked. Okay, or a red tile is picked. Once a red tile is picked out of the bag, and I'm going to do that. Okay, on this side of the screen here. I'm going to pick these tiles out of the bag. As soon as a red chip is picked, then your game is over. Okay, so the people who picked bag A, you have accumulated all the points you will get, and then the game moves to bag B. Okay, then a chip from bag B is then randomly selected. If it is blue, same process. Everyone who picked or pre-selected bag B as the winner will get a blue token or a point. Okay. But if the chip is red, the game is over. Okay, so just like bag A, if the chip is blue, the process repeats until a red chip is picked from the bag. When the game is over, the students with the greatest number of blue tokens or points are considered the winning team. All right, so without any information about the bags, you'd probably select a bag simply by guessing. Okay, if you had no information whatsoever, you would just have to guess. Okay, but surprisingly, the show's producers, whoever they are going to allow you to do some research before you select the bag. Okay, so now this, again, this is a very, very good and very applicable lesson to the classroom. This whole idea of research. I mean, and again, bringing more of a scientific emphasis to this math content. Quite interesting and quite a good idea. All right. So for the next 20 minutes, we're going to change that 20 minutes. You can pull a chip from either one of the two bags, look at the chip, and then put the chip back in the bag. Okay? You can repeat this process as many times as you want within the 20 minutes. Now again, that's if we were in class. That's the end of 20 minutes. You must make your final decision and select which of the bags you want to use in the game. Now, let me just repeat, we will not be using this process exactly. There will be a research phase, but of course you're not going to be able to do it at home because I, as the teacher, am preparing these bags. Okay, only I should know what number of each tile are in the bag, in the bags, bag A and bag B. So we're not going. We'll have to make it. We'll twist it. We'll twist it a little bit, and we'll make it work, and we'll have some fun, and hopefully this, in the end, will lead to a greater understanding of something for you, though I'm not quite sure. But anyway, here we go. Let's continue. So now getting started. So assume the producers of the show do not want to give away a lot of their blue tokens, which would make sense. Okay, these blue tokens may cost them money, just like any producer of any game show. They surely they want to give something away, because if they give nothing away, then nobody cares. Okay, because nobody wants to go on a show where you are guaranteed to lose. But they sure don't want to give a lot away. Okay. So as a result, if one bag has the same number of red and blue chips, do you think the other bag will have more or fewer blue chips and red chips? And I went ahead and hit that too early. Explain your answer. Well, I would think fewer. Okay, I'm thinking fewer because they're going to let you know, okay, hey, a 50-50 chance here. And again, we talked about 50-50 chance in class, and boy, it sounds great, doesn't it? 1 out of 2 chance, but as good as it is as bad as it is, okay? Because 50-50 chance of winning and a 50-50 chance of losing as well, okay? So while that sounds like a great odds there, 50-50 to most of us, that is the best probably these producers will want to give you. So thinking the other one would have fewer blue, though can't be absolutely sure because it could be better, and they might be hoping that everyone picks the 50-50 bag. Okay, you don't know, but that would be up to you to predict there. Okay, so now this research phase here. Okay, so planning your research. All right. So again, we're not going to do this, of course, for you, but you would have 2 bags labeled A and B, and I do have those bags here. And here they are. That is the sound of bag B, and that is the sound of bag A. Hope that didn't sound too loud. Anyway, so we had this 20 minutes. Now we're not going to go ahead and do 20 minutes. Let's just say 40 picks, okay? And I'm going to do that picking, okay? So we have 40 picks to experiment with pulling chips one at a time from the bags. And again, if we're in class and like me here, we're not just going to pick just from one bag, okay? We can pick from both bags. We can go back and forth and just and again, I think that the biggest point here is to record your results, okay? So, and again, after you examine the chip, you have to put it back, all right? And again, that's with replacement, all right? Remember, no peeking in the bags. Of course, you don't have any bags, so you can't peek. And like I just mentioned, you can pick from just one bag the whole time, because, you might say, hey, A, I know what A is. It's a 50-50. Let me just go ahead and focus on B, all right? Or you could pick from one bag and then the other bag. All right. So use the results of these 20 minutes of research to determine which bag you will choose for the game. Okay? All right, and so if we're going to provide a description outlining how you will carry out your research, well, right now I, Mr. Natali, will conduct the research for you. You just collect the data. Okay, now you might want to go ahead and just write down how you might plan to carry out this research, and then discuss it with your mom or dad or buddy or even me. Okay, yeah. So just to get ideas of what you would do. Maybe you agree with me that I would that I would go ahead and do one. I would focus on that bag B. Okay. All right. Here's where we're going to collect data. Okay, right over here. Won't quite do that yet. If you want to, just find a place somewhere on your paper there, in your binder, or also just grab a piece of paper. Okay, and just have that ready to go. Okay, so but we're going to move ahead here, and that's wrong. That's not what I want to do. Okay, so right here is this here. Sorry, it's when I skip around, it's a real big pain. Okay, so this is a wonderful, again, like I said, this is a really wonderful application to the classroom. Okay, so you'd carry out your research, and then you're going to share. You would share your plan. Actually, before you carried out research, you would share your plan with your teacher, with me. Okay, which is good stuff, but not practical in our case. Okay, but you can see how good it is. You know, I could look at your plan. I could verify whether your plan is within the rules of the quiz show. Okay, and again, the approval, would not mean that I'm indicating that your research method is the most accurate. Okay, but if I approve it, then you can go ahead and carry out your research as planned. So again, as you can imagine, really good for the classroom. Okay. So why don't we do this? Let's go ahead. I'm going to go back to the page where we record our data, and let's go ahead and carry out that research. Okay, let's go ahead and carry out our research right now. Okay, well, I have bag B here ready to pick out of, and what I'm going to do is go ahead and pick, excuse me, 20 times in a row from bag B, and then I'll come back and show you my results. Okay, so just hold on one sec. Okay, welcome back, and let me just show you. I'm dipping into bag B and show you the results of those selections. And as you can see, there were only 1, 2, 3, 4, 5 out of 20. So 5 out of my 20 roles here, or selections, I made were were blue. Okay, and that means 15 out of 20 were red. Okay, so based on that, I don't think I need to select anymore. Could continue, but I don't want to prolong this lesson because, like I said, I'm not sure in the end of, again, besides being a really fun classroom activity, how much this is going to help you. But anywho, yeah, so let's go ahead, and how about you now make your decision. Okay, you've got to decide now based on the above research, and again, select bag A or bag B, which will yield the most blue, and again, blue tokens or whatever points. Okay, and again, we know that bag A is 50-50. Okay, it is. You have a 1 out of 2 chance of getting a blue, 1 out of 2 chance of getting a red, and here you have, like we said, 5 out of 20 or 1 out of 4 of a blue, but a 3/4 chance of getting a red. Okay, and red is what we don't want to get. Okay, so go ahead and make your selection. All right, and then let's go ahead and move forward. Okay, so we carried out our research already. Okay, so let's get to playing the game. Okay, so let's go ahead and play this game here. All right, I'm first going to shake up bag A. Okay, I'm going to get bag A going, and then we're going to keep track of our, excuse me, our bag A tokens. Now, the way we collect tokens, of course, is when we select a a, a blue. Okay, we select a blue. All right. Here we go. Shaking it up. This is bag A. Haven't touched it yet. Okay, so here we go. I'm just gonna. Now, if you might have selected bag A, oh, that was blue. Okay, the first one was blue. So bag A people, those of you who chose bag A get a token. One so far. Oh, another blue. Okay, so that's your second token. Okay, you're probably feeling really good by now. Okay, about this. Bag A again. Oh my gosh, another blue. All right, and another shake and a red. Okay, so so a red stops it. So you bag A people receive 3 tokens or 3 points. Okay, so let's see what happens with bag B. Okay, so now I have a little place here to record my bag B tokens. Now again, if you chose bag B, might not be feeling very confident because I picked a red. So, wah, wah. Okay, yeah, that's it. But that's okay. Here, let me try pick another. I'm just try it. See if I can actually get a blue one. I did get 5 out of 20 before. Another red. Okay. Well, anyway, that was really wah wah. Okay. So if you did pick bag A and you chose that 50-50, 50-50 chance, you did well. Got 3, won yourself 3 tokens. You can cash those in when I see you next. Bag B people, no tokens. Maybe you took a chance. You thought, hey, let me give it a try. Bag A could have gotten a red one first. They could have, okay, but they didn't. All right, 50-50. Bag B, and of course, if you did decide not to choose bag B, I'd be quite proud of you because truth is, it did not look like the odds were on your side to do so. Oh, okay, so let's go ahead and pretty much end this lesson by you examining your results. Okay, examining your results, and the way to do that here is at the end of the game, your teacher will open the bags and reveal how many blue and red chips were in each bag. So let me go ahead and just write that down here. We had bag A, and then we had bag B here. And in bag A, there were 5 blue, and as promised, 5 red. Okay, so there was a 1-to-1 ratio. Now in bag B, there were but 3 blue and a whopping 9 red. Okay, so yeah, the odds were highly on the red being chosen in bag B. Okay, so now you know that's actually what was in the bags. Okay, so now if you would go ahead and just answer these questions that follow, all right, and that is the rest of this the rest here. And how many questions are there? I think there are 6, is that right? Yes, so 6 questions. Go ahead and pause here, read these questions, answer them to the best of your ability, and this is probably the most important part of this lesson. It's just that you can give some thought to the results of your experiment that just took place. Okay, and then come on back. We'll look at those questions, and then we will close this lesson. Okay, so we're back to debrief here. Again, not a perfect situation to debrief either after I'm reading these questions and answering them myself, because it was was I who did the research. Hopefully, you answered them. Maybe just thinking how you might have actually done your research if you had actually done this in class. And again, this might be something that'd be really fun. I would highly recommend that, either your mom or dad or whoever's working with you, or a sister or another friend, maybe put together two bags and go through this process. It won't take very long. And again, go through the research and make your decision as to which bag would be better odds, a greater probability of picking blues, and see what you come up with. Okay, but anyway, let's go ahead and answer these questions, and again, you can think about what I say and what it might mean. So before you play the game, what were you trying to learn about the bags from your research? So that question would be, what are you doing via the research? Okay, so for me, I was looking for estimated probability of bag B. Okay, so what I was relying on bag A's theoretical probability, and we've talked about the difference between these two, this idea of estimated versus theoretical. Okay, now I had a theoretical probability of bag A, okay, because I knew, well gosh, I guess I didn't know that bag A. Well, choosing bag B and then getting that tremendous number of reds, okay, would have shown me, or again, it doesn't prove, quote unquote, prove anything. It simply suggests highly that was not a 50-50 bag. So once bag B yielded the results it did, I went ahead and just made that assumption that bag A was the 50-50 bag, and then just relied on that theoretical probability. But I could have gone into bag A and picked as well, and I'm not sure exactly what you might have done, but thinking through the process, really important. And like I said, I shouldn't say it again. I'll say it one more time. This would have been a great thing to do in class. Anyway, continuing on here, number 2. What did you, excuse me, what did you expect, or what would you have expected to happen when you pulled chips from the bag with the same number of blue and red chips? Did the bag you thought had the same number of blue and red chips yield the results you expected? Well, truth is, I didn't even bother picking from that bag, and I just kind of guessed that bag A was the 50-50 bag. Okay, I focused on bag B. So if bag B had yielded different results, okay, and might have looked more, or the results might have presented more of a chance of it being 50-50, okay, half and half, red and blue, I might have pursued A. But because of its overwhelmingly slant towards red, I went ahead and just decided I was satisfied with the fact that A was the 50-50 bag. Okay? And so number 3 asks, how confident were you in predicting which bag had the same number of blue and red chips? Explain. Well, not actually applicable. I'm not sure why I wrote that, not actually applicable, because I felt pretty confident. Okay, I felt pretty confident actually, because like I said, bag B had yielded such a slanted, look at, what I had, when I did my 20 pulls, I had, 5 blue, right, 5 blue, and then 15 red. Okay, so it was so overwhelmingly red that I was highly confident, I would say. And explaining, well, I'm not going to explain. Highly confident, okay? And you know why. I've explained that already. Okay, and what bag did you select? Well, I'm not sure which one you did after seeing my research results. Okay, but yeah, I would have picked, of course, bag A, okay, because of the research results of B. Okay, based on the research results of B, and kind of taking a chance. You know, I wanted to rush through it. Maybe it was kind of rushing. Okay, I didn't want to pull a whole 40 times, or surely not for 20 minutes. Whew, I can't imagine what that would be like. But anyway, yeah, I picked A. And now, if you were the show's producers, how would you make up the second bag? Okay. Now, remember, one bag has the same number of red and blue chips. All right. So if you think about it, again, we talked about, a show that where there are no winners, where it's impossible to win, is not fun. Okay. So any kind of game, like the lottery, or scratch off lotto tickets and all that kind of thing. I mean, it's not fun if you never win. Okay, and no one's ever going to want to play again, right? So you have to make it kind of easy. But the 3 blue and 9 red, I thought for me was a little bit overkill on the lose side. So I think I would make the probability better than the 1/4 or 1 out of 4 in bag B. So if you had one that was maybe 50-50, which was like bag A, 50-50, 1 out of 2 chance. That should be your best. Still, I think maybe a 1 out of 3 chance or something, for the other bag. So what would that mean? You'd have like something like 3 blue and 6 red, or something like that, or 6 blue and 12 red. Okay. So something like that. These yield a bit of a better chance than what we had, what I had put in the other. Well, actually, 6 and 12 isn't correct, right? That's not 1 out of 3. It'd be 6 and 9, right? 3 out of 9, 6 out of 15. Yeah, that's right. So, yeah, something like that. I would make it a little bit better odds, but I would not, if I were the show's producer, ever give them a better chance of 50-50, because then I'd be giving away too many blue tokens. Boy, those blue tokens, they are really valuable. Anywho, so last question here. If you picked a chip from bag B 100 times and found that you picked each color exactly 50 times, would you know for sure that bag B was the one with equal numbers of each color? And this is a big claim right there, for sure. Okay, I underlined too. So let's say quite confident, but not for sure. Okay, if you don't know and you are not actually given the number, the bag that had the 50-50 in it, to be absolutely confident when you are dealing with estimated probability is not probably not a suggested way to approach it. You can be quite confident, okay, but never can be sure, because even though that other lousy bag B had 3 blue and 9 red, still could have picked, if you picked 100 times, okay, we still could have gotten a 50-50. I mean, it can happen. It can happen. People win the lottery, 1 out of so many million chance. It does happen. But we still can say, based on an estimated probability, so estimated probability is going to yield us a level of confidence, but never certainty. Okay, and here's our lesson summary. Again, I hope this lesson was worth anything at all. The long run relative frequencies can be used as an estimated probabilities of events. Okay, and this idea of long run, we didn't really do. 20 minutes would have been long run. Okay, you would have plenty of picks. But these long run relative frequencies, okay, long run is going to help, and the longer the run, the greater the number of picks, in theory, should make our estimation better and better. Okay, collecting data on a game or chance experiment is one way to do these things, and then the more data collected, on the outcomes from a game or chance experiment, the closer the estimates of the probabilities are likely to be the actual probabilities, which is exactly what I said up here, and which seems to be the same, saying pretty much the same thing. So again, collecting more data is going to get us closer, or make our estimates closer. Okay, well again, I hope you enjoyed that, and go ahead and tackle those problem sets, and I'll see you next lesson.